About parabolas today.
Aye.
And parabolas are interesting in that they're the first form of a quadratic that you get taught. But they also happen to be an extremely important conic section. And when you examine parabolas as conic sections, you discover all kinds of things that you didn't know when you looked at it as a quadratic. For the moment, let's go back and look at what your basic parabola looks like. That is y equal x squared. Now, when I say basic, that's with its vertex at the origin. The more complicated format for a parabola is what's called the vertex format. And what is h and k in the vertex format?
The point.
That's the vertex. In other words, if I had y equal 2 times x minus 3 squared plus 4, tell me what the vertex is.
3, 4.
3 comma 4, yes. Now, what A is a measurement of the vertical stretch or the vertical shrink factor. In other words, if I had an A of 2, then it would look like this. If I had an A of 1/3, it might look like that.
Yeah.
Okay, good. All right. So, vertex format is a key format. It's not, unfortunately, the only format you have to deal with. They probably have introduced you to other formats. Tell me if you have seen this format. That one? Familiar with that?
Yeah.
Okay. Now, the only difference between these two formats, that one and that one, is that A is equal to 1 over 4p. That's it. Notice that if we make A equal to 1 over 4p, and we move the k on the other side of the equation and multiply both sides by 4p, I've got that. So it's just an algebraic manipulation to get from vertex format to, I don't know what this would be called, I guess conic format. And the advantage of conic format is P is very valuable. P is the focus. And when you're looking at a parabola, where the focus is located is extremely important. There are certain reflective properties of parabolas where every ray that comes in vertically gets reflected to exactly the same point, and that point is the focus. So if you're designing a dish to receive signals from stars from outer space, you design it in the form of a parabolic dish, because all the rays come down and no matter where they hit, they reflect to there. If you're coming down there, even they reflect to there. Even if they come down right there, they reflect to there. So when you go outside and you look on top of rooftops and you see everybody having a direct TV dish, and you see that receiver, That's where the focus is. And so what's really important about parabolas is their reflective property and where the focus should be put.
Okay.
And this is the equation that relates the two. Now, myself, I would be in favor of only using the vertex format and just giving you this part, a equals 1 over 4p, and going from there. Unfortunately, most of the school systems insist upon you knowing the vertex format, also knowing the conic format, the one I have at the bottom. They're quite confusing to a lot of my students, but they're not as long as you realize that a equals 1 over 4p. All
Okay.
right, let's look at these problems. All right, this is fairly straightforward.
Okay, so I sent you two. One of them starts with 7.
Okay, so you want to start with the second one.
Yeah.
All right, I can do that. All right. Give me the equation in vertex format. Hold on a second. Sharp. What's the vertex format?
So
Wow. Hold on a second. It's a new program. I'm not quite sure what it's doing here. I guess the size I would want. All right, we'll go with that for a moment. Hold on a second. So this is the vertex format.
all right.
Okay. Now it says that the vertex is at 6, 18. What does that tell me?
So that's the vertex.
So
So
what do I know? Don't know A yet, but I know H and K. Tell me what H and K are.
H is positive 6, so x minus 6,
Okay.
and plus 18.
All right. Now they also tell me that that point lies on the parabola. And for a point to lie on the parabola, it has to satisfy the equation. Okay? And what
Okay.
we're really trying to solve for at this point is A. Well, if I substitute that point in for x and y, the only variable will be A, and I'll be able to solve for it.
Right.
So what's the next thing I should write?
So 12 equals, oh crap, 2, or A, then 2 minus 6,
Hold on. Okay. Okay.
plus 18.
All right. And then if I do a little algebra here, I get minus 6 equals minus 4a. And I get a equals a positive 3/2.
So
Now
yeah.
what's the equation of my parabola?
So f of x or y equals positive 3 over 2, then x minus 6 plus 18.
Okay. All right, so we've written the parabola in vertex format, then solve using square roots to find the zeros of the function. Well, what do they mean exactly? Ooh, like this. Hold on a second. Let's see what happens. All right, I'm gonna like this better. All right. So here's our equation of the parabola. When it says solve using square roots to find the zeros, what am I going to do? And this is there's a square right there also. That's x minus 6 squared.
Oh, yeah.
Okay. So
All right.
how do I find the zeros of that parabola? And the zeros merely mean where it's going to cross the x-axis. In other words, there's going to be a 0 there and a 0 there. Okay, so how do we solve for it? Using square roots.
Okay.
What does y have to be equal to when we're solving for the zeros?
It has to be equal to the square root. Or the
Equal to 0. When I drew that picture, I drew a parabola. Well, the zeros of the parabola are that point there and that point there. And what's the y value on both of those points? 0.
Yeah.
So that's why we set y equal to 0 when we're solving for the zeros of the function, is because that will give it.
Okay.
Okay. Now we need to solve that. So what's the first step in solving this equation on the 3 halves?
So you subtract 18 from both sides.
Okay. I don't like where this is headed. What mistake have I made? Maybe none. Maybe none. Let's keep going. What's next?
Okay. You divide by 3 halves.
Which is the same as multiplying by? Same as multiplying by 2/3. And that's kind of what I remember as a rule. Is what you do is multiply by the reciprocal.
Okay.
Both sides. Okay. Obviously, everything's going to cancel over there. You're going to end up with x minus 6 squared equals 12 minus 12. Use different color ink. This pink color is beginning to annoy me. Now what?
Okay. So then you square root both of them.
Okay. So what's the next line?
So the square root of 12i equals x minus 6.
Is square root of 12 simplified?
Yes, it can.
What is it simplified to?
3 square root 2. Or, wait, no, other way around. 2 square root 3.
2 square root 3. So it's really 2 square root of 3i equal x minus 6, which means x equals, oh, and by the way, it was plus or minus.
Right, yeah.
In other words, let's go back to that general rule. If ever you are solving an equation by taking the square root of both sides, which is what we did, you begin your answer with the words plus or minus. So what we end up with here is 6 plus or minus 2 root 3i. And those are the zeros of our parabola. And the fact that we get an imaginary solution merely means it does not cross the x-axis.
Okay.
If you do not cross the x-axis with your parabola, then you are going to have an imaginary zeros. When you have imaginary zeros, they're not zeros that cross the x-axis. So that's kind of what you find out when you go to solve this, is that it's not going to be a parabola that crosses the x-axis. But
Okay.
nonetheless, we've done everything we need to do on it. Hold on. Get rid of that. Try this again. You want to just go in order on these?
Yeah.
Okay. So we have a function here that already has quite a few transformations done. The 4 is a vertical shift. Minus 5 is a horizontal shift to the right. Excuse me, the 4 is a vertical stretch. The 5 is a horizontal shift to the right. And the 9 is a vertical shift up. That's from the basic function y equal x squared. So you could graph this by doing all of those things. But now they're taking it to the next level and they're saying that this function is vertically shrunk by a factor of 2. What does that mean? Let's say h of x is what? If I were to take that function and vertically shrink it by a factor of 2, what would it look like? If that's all I did.
H of x equals 2.
It would be 2 instead of 4. In other words, it would be the whole thing. And now, if I took this h of x and I shifted it 3 to the right, what would it look like?
So, it's x minus 8. So, h of x, or of x, equals 2x minus 8 squared.
And now do the final one, 6 down.
Minus 3. Or plus 3. Sorry.
Well, no, it's, in other words, we started at plus 9. So all we're doing is doing down 6 from plus 9. That gets us to plus 3. So there's your result. In other words, the difference between k of x and j of x is exactly what they have said.
Okay.
So we're not always transforming just the elementary function. Most of the time we are. But a lot of times we're taking functions that have already been transformed and we're transforming them further. And that's what this problem is all about. All right. Number 9, parent function. Tell me what the final result is. Give it to me one step at a time. This time I'm just going to write it by y. Now, hold on a second. Let me circle. Do those need to be done in a certain order?
Yes.
What has to be done first?
The shifted left 2 and up 7.
No, all reflections.
Okay.
Always. All reflections. So it doesn't matter whether it's a reflection over the x-axis or a reflection over the y-axis. You do those first. So the very first step, and I'm just going to call each of these steps y. So that would be a reflection over the x-axis. Now what? And now the order that you do the rest of the steps doesn't matter. What is shifted left 2 translate to? This time I'm going to change the color of each one. So if I were just doing the reflection and shifted left 2, what would it look like?
So y equals negative, and then parenthesis x plus 2, parenthesis.
Correct. Exactly like that.
Sorry.
And that's just that part and that part. And now finally add the up 7.
So plus 7.
What's the final answer that they want? Write the equation and name it g of x.
So g of x equals negative, parenthesis x plus 2, parenthesis squared, plus 7.
Yeah. And obviously the parentheses here is extremely important.
Right.
Always need that, regardless of what you're pretty much doing. All right. Let's go to the next one. All right, this is a really standard problem, not just in math, but in physics. Have you taken physics yet, Demetrius?
No.
Are you taking it before you graduate?
I don't know. I might.
Okay. This is an equation you're going to run into a lot. And because this is the equation that models, that 16 is there because of the force of gravity being 32 feet per second per second. So this equation governs the height of anything t seconds after it's been released. If you were to drop a penny from the top of the Empire State Building, then this equation would cover it. Wouldn't this exact equation cover it, but that very similar equation. It would be a minus 16, it would be squared plus whatever the height was. All right? What they're telling you is that this particular h of t equation is going to model Branson's height. relative to time. Okay?
All right.
So sketch a graph of the parabola, including labels on each axis. Okay? Let's do that. What's my horizontal label going to be?
So
It's going to be time. Time is always going to be your horizontal label. And in this case, it's in seconds. What's the vertical axis going to be?
Height.
Yeah, h of t, which in this case is height. Okay? So they said, let's graph it. Well, where's the vertex? That's a good place to start.
So we need to solve it.
What's the x-coordinate of the vertex? In other words, they're giving it to us in exact vertex format.
Okay, so it's negative 1.5 comma 60.
Right? We'll say that that's right there. I'll label that negative 1.5 comma 60. This parabola and all projectile motion is modeled by parabolas. That's another beauty of parabolas. It's amazing how many things in the universe are controlled by quadratic equations. Okay? Does this open up or down?
Down.
Correct. In other words, I'm just going to approximate it for the moment. So I know I'm looking at something like that. Now, including labels on each axis, we've done that. The only thing we haven't put on there is the y-intercept and the x-intercept. We'll get to that. So we've done A. What's the maximum height off the ground that this clown achieved?
So 1.5 comma 60, right? Or
Maximum height. Which axis is the height?
60 feet.
Exactly. 60 feet. All right. In other words, his cannon is right there. You see where I'm drawing that dot?
Yeah.
That's where he's being shot out of the cannon. He's going up to 60 feet, and then he's going to come back down.
Okay.
But clearly, he's being shot upwards, just according to the problem, if nothing else. But so how long did it take Branson to reach this maximum height?
1.5 seconds.
Yeah, sorry, I put a negative sign there. I didn't mean to. That's correct. And how long did it take Branson to hit the net that is at ground level? In other words, what is the t value when he hits the ground? And how do we figure it out?
So we just solve for t.
What's h of t when he hits the ground? What's the height when he hits the ground?
0.
Aha. So we're going to make that 0 and solve for t. So let's do that. We got 0 equals minus 16 t minus 1.5 squared plus 60. So let's solve that equation for t. And notice we're going to get two answers. One of them is that one, and the other one is that one. Well, the only one we care about is the one on the right, because the
Right.
one on the left never existed. In other words, you don't have
Right.
negative times. You always only have positive times, in the same way that geometry, you only have positive dimensions. So if I solve this equation, I'm going to get this. It would have been nice if they could have given us round numbers. Let's see. 15 fourths equal to that. Now if I take the square root of both sides, I'm going to have this. And normally I would say plus or minus is the answer, but I know in this case it's only the plus that is the answer. So now t is going to be equal to 1.5 plus, well, that's square root of 15 divided by 2. So that is the time where it hits the ground. In other words, if I were labeling that spot right there, it would be 1.5 plus square root of 15 divided by 2. That would be the x-coordinate. The y-coordinate would be 0.
All right.
With me there?
Yeah.
All right, good. Switch to black ink. I don't like the way this ink's showing up on this page. So, if I can't scroll up here. Does the next page begin with 11 or not?
Yes.
Okay, so I can go to the other page. Well, not quite, it doesn't.
Oh, oops.
But I think I can figure it out. Well, maybe not. Hold on, let me go back and read the first part. Heck. Looks like the first page. Oh. Sorry. I forgot this one on the right was the first page. All right. Model rocket is located on a platform 22 meters in the air. The equation of the model rocket's altitude in the air is, all right, I wonder if I can bring up both of these at the same time. And I can switch back and forth. Though I don't think I can. All right. Notice that the height is the constant. In other words, the initial height. If the initial height is the ground, then it's not going to have a constant. And also notice that the initial velocity is the coefficient of the t, 60, right there. And there's always a negative sign in front of the coefficient of the t squared because you always have gravity acting in a downward motion. So you're always going to have parabolas like that. You're not going to have parabolas like that ever with projectile motion.
Okay.
Okay? So complete the square to put it in vertex format. Let's do that. First of all, give me vertex format.
So,
It's always the way you want to start math problems, is with the general format.
so y equals negative 5t squared.
Oh, don't look at the function. Give me the general format.
Oh, so y equals a x minus h squared plus k.
That's the general format. And that's what we're going to try to make this equation look like. Okay? Now, what we have is p of t equals minus 5t squared plus 60t. And I'm going to set this 22 a little bit off to the right. And what's the next step to completing the square?
So,
In other words, this quadratic they gave me is in standard format. It's not in vertex format.
right.
So we have to convert it to vertex format by making it look like the vertex format. So we set the k, which may not be 22, but it's the number for the moment. We want to put parentheses around everything that's got the t. So we want to put parentheses around that. Now, I cannot complete the square until what? What do I have to do first?
you have to isolate it.
You got to factor out that coefficient. In other words, for you to complete the square on something, you have to have the coefficient of the squared term to be 1. So I'm going to factor out a minus 5, leaving t squared minus 12t, and then I'm going to leave room to complete the square. Now the key when you're doing completing the square is just make sure that every single line you write is the same as the previous. You see where I did not change anything. If I take the bottom line and put it back together again, I've got the line above it. See that?
Okay. Yeah.
And you always want to check that. Every single step, you want to check that. Because that's the easiest way to make a mistake, is to make a mistake when you go from one row to the next row. Notice that we're getting closer and closer to our general format. Well, how do I complete the square inside the parentheses? What's the technique?
So you, how my teacher says it, so half the middle, so
Right? Which is?
negative 6, and then square it.
Okay, so what's that?
So t squared minus 12h equals...
Oh. Negative 6 squared is what?
36.
Always adding. because whether it's positive or negative, it's going to be a positive once I square it. Okay? So I just completed the square inside the parentheses. Unfortunately, I have changed the function by quite a bit. How do I balance out the fact that I just wrote 36 in there? In other
You
words,
add
this is no longer the same as the previous row. So what do I have to do?
add 36 to the other side.
How much did I actually change the equation by when I wrote 36 in?
-5 times 36.
Yes. What did I really do?
You
I subtracted 180.
yeah.
In order to balance it out, I got to add 180. Now, this equation is identical to that equation. If I unwrap it, I got the same thing. That is once again the key to these things. Now, the whole reason I completed the square was so that I could write this quadratic that's inside the parentheses as a binomial x minus h squared. Well, what is it? It's t what? T minus what squared?
T minus -6.
Well, just t minus 6.
Oh yeah.
Okay? It's always going to be either t plus or t minus, and it is whatever the sign of that middle term is. In other words, if I square t minus 6, I get this, what I had above it. And then combine the two constants, and I got 202. So again, my bottom row is the same as my starting row.
Okay.
The only difference is now that it's in perfect vertex format. So tell me what A is, tell me what H is, and tell me what K is.
So A is -5. H is 6. And K is 202.
All right. So we've answered part A. What's the second part say? How long did it take the rocket to reach its maximum height? How long?
So it took it 6 seconds.
Exactly. In other words, it is the t-coordinate of the vertex. The t-coordinate of the vertex is where it reaches its vertex, which is the maximum height.
Right.
What was the rocket's maximum height?
202 feet.
Okay. Sketch a graph of the parabola and label its axes. Well, I'm going to do that real simple over here. My vertex is at 6, 202, somewhere like that. Obviously going like that. That's time. That's height. And that's the common thing on all of these problems that are about projectile motion or rockets being fired into the air. It's always height vertically, time horizontally. And you can picture it, rockets being fired. In other words, at time 0, what's the height of the rocket? Where's that y-intercept? They didn't ask it, but I'm going to. because it's an important point on this graph. We can't really graph it properly if we don't have at least the y-intercept. We know where the vertex is, but we don't know where the y-intercept is, and we haven't figured out the x-intercept. Well, the y-intercept's much easier to figure out. First of all, what is t? What is t on the y-intercept? What's the t coordinate right here? Time is the horizontal coordinate. What is it?
0.
Okay, so plug in 0 for t, and now you have minus 5 times minus 6 squared, which is 36. That's 180. So it's minus 180 plus 202 plus 22. So that the rocket was fired from a height of 22 meters. Oh, that's what they told us to begin with. We knew that already. In other words, I didn't need to go back and solve for it. I was forgetting what the problem was. All right, let's go to 12. Let me do this. Get a little more writing space if I do it this way. All right. The way you always do these parabolic dish problems is you draw the axis and you put the vertex at the bottom, or at the origin, excuse me. So there's the parabolic dish as looked upon from the side. Now, they've told us that it's going to be 126 feet deep and 384 feet in diameter. Can you give me the points of these 3 points? Upper left. What's that going to be?
So 126, 384, or comma 384?
The diameter's 384. That means it's 384 from my left point to my right point. So what are the coordinates on that left point?
So 384, comma 126.
First of all, let's do the horizontal. It's not 384, it's half of that.
Oh, right.
So it's minus 192. And what's the height?
126
And the other one?
is positive 192 and then 126.
And this one is 0, 0. So we have 3 points on a parabola. We are going to be able to figure out everything we need, I believe. Let's do these. These always used to give me a little bit of a problem. Not sure why. Let's see. Sketch the parabola as though you were viewing the dish from the side. Okay, I think we've done that. Define a sensible point to be the origin, then find the coordinates of the vertex and one other point on the parabola. We've done that. Use your given points to find the value of A in the vertex form of the equation. What is the vertex form of the equation?
So y equals a x minus 0,
Okay.
because the vertex is 0, 0. So
Right. Okay, so that's it. Okay, now we just have to solve for a. So that's our vertex format when the vertex is at the origin.
right.
Now all we have to do is solve for a. How do we do that?
So
Remember, this is the equation of what we have drawn. So every single point on the graph that we drew has to fit this equation.
so 192 for, oh wait, no, 126 for y, and then 384 for x.
Oh, what's the x coordinate?
192.
Yeah, 192, not twice that. Okay.
Right.
And that allows us to solve for a.
Okay.
It says leave your answer in the form of a fraction. So I end up with a being 126 divided by 192 squared. And notice that it is plus or minus. Well, no, it isn't. Excuse me. It is not plus or minus. It's plus. This thing opens up for sure. So A is definitely plus. But whatever leave your answer in the form of a fraction. Let's play with that a little bit because that's not so obvious what she means. That's what A equals. What do I do with it from here?
So the denominator, you can just do that. So
Well, it's easier if you don't do that. In other words, we want to simplify this. Okay? We only have 5 minutes here. So let's spend it on this algebra. And that's all this is just algebra. To simplify that, notice it's going to be hard to do on a calculator because a calculator is going to give you a decimal answer.
right.
We don't want to do it on a calculator.
Okay.
So let's start simplifying this. Is there any number that divides equally into top and bottom?
2.
That's a good start. That gives us 63 over, what is that? 96 times, so now it's 96 times 192. Now is there a number that divides into top and bottom?
3.
Yeah, in other words, if a number's digits add up to a multiple of 3, then you can divide by 3. So that gives us 21 in the top, 32 times 192, so now we're there. And I can divide this by 3, and that by 3. In other words, that adds up to 3. So I know it's divisible by 3. And that adds up to 12, which is a multiple of 3.
Right.
So now I go down to 7 times 32 times 3 goes into that 64 times. Now I think, notice that I have a prime number in the numerator. And I don't see the denominator being a multiple of 7. If the denominator is not a precise multiple of 7, then I can't simplify it. I can only multiply it. Now you got to use your calculator, come up with 7 over whatever 32 times 64 is. So that's not the final answer, but it's close.
So it's 7 over 2048.
And now the only question is, can you divide 2048 by 7? Go ahead and check that in your calculator. Because if that gives you a whole number, we can simplify it.
No, it didn't.
No, I didn't think it did. I don't know any rules for whether numbers are divisible by 7 or not. That's a tougher one. There's some simple rules for divisible by 3, by 4, and by 9, but not so much by 7. So that's probably the answer she wants. And notice that you might have been able to do that on a calculator. Do you have a calculator that's got one button that'll convert a decimal to a fraction?
I don't know.
Some calculators have that. And if you have that, then you can do that whole problem on a calculator, come up with a decimal, convert it to a fraction. It'll tell you 7 over 2048. But if
yeah.
you don't, you got to do it the hard way, which is what we did. And we did it in like 4 steps.
Yeah, I got one, and it was 292 and 4/7.
And then when you converted it, it was 7 over 2048?
Yeah.
Okay. So you could have done the whole thing in 1 step or 2 steps on your calculator. All right. So let's see. There's more to this page or not? Is that it?
Nope, that's it.
Okay, good. We're out of time. So I'll get more material for Thursday's session.
Yes.
Sounds good.
All right. Cool.
I'll talk to you on Thursday.
Okay.
Bye-bye.